Here's the first review video for our first exam, and this first page of the solutions includes the instructions, so I may as well take a moment to say just a couple of things about these. I think everybody taking this class can read, so they're pretty self-explanatory. But I do want to point out that you should show work even if you are using a calculator, but you want to, or you will need to state how you use the calculator. Don't just say used calculator here. Tell me what the keystrokes were, tell me what the process was when you use the calculator. Also, in addition to these three rules, don't forget you are not allowed to use a pen on any exam or any in-class work that you hand in. Anything you submit has to be written in pencil or some other marker that can be neatly erased. That's the whole point. Don't just fill it out in pencil and then scratch through any mistakes. That's why you use pencils, so you can erase. So I start with question 1 here, and we're asked to determine all solutions for this equation. And since we have a square root on the right, of the side of the equation, we want to square both sides to get this radicand. That's the expression inside a radical. That's what it's called. And so we want to get that out by squaring the square root. And when we square the left side, x plus 3, that is a perfect trinomial square. Square the first, x squared, plus the first times the second times 2, which is 6x, plus the square of the second term, which is 9. And when we subtract 39 from both sides, we get negative 30. And when we add 7x to both sides, we get 13x. Then, the most efficient, usually, way to solve a quadratic equation is to set everything equal to 0 and factor, and this trinomial factors pretty easily. So this is x plus 15 times x minus 2. 15 times x is 15x, positive 15x. X times negative 2 is negative 2x. You add those two together and you get 13x. So that makes one possible solution, x equals negative 15, and the other possible solution is x equals 2. And I say possible because they may not both be solutions. This happens quite often when you square both sides of an equation. So we check the negative 15 here by substituting the negative 15 in for x, and negative 15 plus 3 is negative 12. And then we substitute the negative 15 in for x here, and 39, now minus 7 times negative 15 is the same thing as 39 times 7 times 2, which is 105. So that sum is 144. The square root of 144 is 12, positive 12. Well, positive 12 is not equal to negative 12, so this solution is not, it's extraneous, it is not a valid solution. But when we check the other side and substitute 2 in for the x here, and for the x here, we find 2 plus 3 is 5, and 39 minus 7 times 2, which is 15, 14, is 25. Square root of 25 is 5, and so that is the one solution to this equation. Now, in question 2, we are asked to determine the domain of these functions. The function in letter A is a rational, and so we set the denominator equal to 0 and solve. That couldn't be easier, I don't think. And that gives us, remember, that gives us the excluded values when we are taking, when we're finding the values that make the denominator of a rational or a quotient 0. We're looking for excluded values. So the domain of f is defined to be the set of all x such that x is not equal to 5. So that means that the domain of this function is all real numbers except 5. 5 is the only value that cannot be in this domain. Now, in the function in part B, we have a fraction, a quotient. It isn't, strictly speaking, a rational function, but it is a quotient. And we have a radical. We have a square root. And so we need to check. In this case, we're checking for, we're looking for included values. We're looking for everything that is in the domain. And that's everything that makes the inside of the radical non-negative under normal circumstances. But this radical, this root is in the denominator, so it can't equal 0 either. So we solve the equation to find these 2 points because we want to check the interval to the left of one solution and in between the 2 solutions and to the right of the largest solution. Now, if you think about what this function, x squared minus 8x plus 15, looks like, it's a parabola that opens up, and that means it crosses the x-axis at 3 and 5. So it should be that in between that 3 and 5, the parabola is below the x-axis, and therefore all those values are negative and cannot be inside the radical. We also are not going to have 3 and 5 excuse me, in the domain either, because that would make this radicand 0. We can't have a 0 in the denominator. So once we find these sort of critical numbers, they're called critical numbers in calculus, but once we find these 2 numbers, positive 3 and positive 5, we check in the interval less than 3. Any number less than 3 would be fine. I could have just as easily chosen 0. That would have been a lot easier. But any number that we substitute in to x squared minus 8x plus 15 will give us a positive value, as will any number greater than 5. And I chose 6 because I suppose I could have chosen 10, but I chose 6 because that seemed like that would not be too difficult. I guess 10 really would be the easiest. But anyway, and that's, see, you can use any number in the interval from greater than 5 on to positive infinity. So I chose 6. 6 squared is 36. Negative 8 times 6 is negative 48. You add negative 48 and 36 together and add those to 5, and that gives you 3. So this is negative 12. Negative 12 plus 15 is 3. 3 is greater than 0. So yes, everything in that interval is positive, and so is therefore part of the domain. Now, in between, you can choose any value in between 3 and 4, 3 and 5 rather, and 4 seemed like the most reasonable because it involves the easiest multiplications. So I substitute 4 in here. 4 squared is 16. Substitute 4 in here. 8 times 4 is 32. So 16 minus 32 plus 15 is negative 1. Well, negative 1 is less than 0. We can't have anything in this radicand that makes that gives us a negative value or 0. And so the interval between 3 and 5 is not part of the domain. So the domain of G is defined to be the set of all x such that x is in, that means this is it's an element of negative infinity all the way up to 3, and I have open parentheses on each side because, for one thing, you can never get to negative infinity. We can't say let's have a square bracket to include negative infinity because you can't ever get there. And then we can't include 3 because that would make this 0, and we can't have a 0 here. Then I use the union symbol to join that interval up with the interval 5 to positive infinity, and of course the 5 is also has a parenthesis next to it to show that anything even the very slightest bit larger than 5 is in the domain, 5 is not. So the domain of G is defined to be the set of all x such that x is in these two intervals joined together. Now, in question 3, we have two functions, two rational functions as it turns out, and we are asked to first subtract one from the other and then determine the domain of that function. Well, in order to add or subtract these two, they need a common denominator, and x plus 2 is a factor of x squared minus 4. And so we multiply x plus 2 times x minus 2 to make that denominator x squared minus 4, so we have the same denominator. And of course, if we multiply the denominator by that x minus 2, we have to multiply the numerator as well. And so when you distribute the x times the x, you get x squared, times the negative 2, you get negative 2x. And then you subtract the, that subtraction is here. And you subtract the x and you subtract the negative 13. And so negative 2x minus x is negative 3x, and negative 13 is positive 13. So that's our numerator, and the denominator is the least common denominator that we got when we did the subtraction. And that's very easy to factor. We almost don't even need to factor it to see that the two values that will make this denominator 0 are negative 2 and positive 2. Negative 2 here plus 2 is 0. Positive 2 minus 2 is 0. So either of those will make the denominator 0, so they are excluded from the domain. So the domain of f minus g is defined to be the set of all x such that x is not equal to plus or minus 2. That is the most compact way to write that. Next, we are asked to simplify the quotient f over g and find its domain, determine its domain. So f over g means f of x over g of x, and so here is f of x, x over x plus 2, and here's g of x, x minus 13 over x squared minus 4. And there are two ways that we can approach this. Either way gives us the correct function. So I'm multiplying here, I'm multiplying numerator and denominator by the least common denominator of these two, which as we saw above is x squared minus 4. So I multiply x squared minus 4 times this function, and x plus 2 is a factor that cancels out of here, leaving x minus 2 as the non-canceled factor. And so the numerator is then x times x minus 2. And in the denominator, well, x squared minus 4 and x squared minus 4 cancel multiplicatively. And so the denominator is just this numerator, x minus 13. So x times x minus 2 is x squared minus 2x, but that is not important, because the important part is the denominator here shows us that 13 cannot be in this domain. So it is the one excluded value. All other real numbers are in that domain. And now the other approach has us write the complex fraction as the numerator divided by x over x plus 2 divided by x minus 13 divided over x squared minus 4, which is the same thing as multiplying the reciprocal of x minus 13 over x squared minus 4. And because of the factorization x plus the factors x plus 2 cancel, and we wind up with the same function we did before. And so the domain of f over g is defined to be the set of all x such that x is not equal to 13. All real numbers are allowed except for 13. And finally, the last part of that question has us multiply these two. And so when we do that, we multiply the x times the x minus 13, gives us x squared minus 13x. And in the denominator, we multiply x times x squared, gives us x cubed, x times negative 4, which gives us negative 4x, 2 times x squared, which gives us positive 2x squared, and 2 times negative 4, which gives us negative 8. Then we order those four terms in descending order and factor those. We see that the greatest common factor of x cubed and 2x squared is x squared. So we factor an x squared out. That leaves the factor x plus 2. Then the greatest common factor for these two terms is negative 4. So you subtract the negative 4 out, and you have the same factor here as you have here. And so factoring by grouping gives us x squared minus 4, x squared minus 4 times x plus 2. Well, x squared minus 4 is the difference of squares and factored as we saw in the prior parts of the question. So x squared minus 4 is x plus 2 times x minus 2, and so we have x plus 2 times x plus 2, which is x plus 2 squared, times x minus 2. And so we did not, and by we, I mean I, did not include the domain there. But the domain of f times g is defined to be the set of all x such that x is not equal to plus or minus 2, just as we have here in part A. Okay. Alright, next is a difference quotient, and I believe I will cut this video off here and start the next one up with that difference quotient.